A progressive wave traveling along a positive x direction is represented by yxt is equal to a sine kx minus omega t plus phi. Its snapshot at t is equal to 0 is given in the figure. For this wave, the phase phi is. So this is the snapshot given of the you can see wave at t is equal to 0, and a is given its amplitude, and we are supposed to find out the phase of this particular wave. So we start from the given equation and we say the wave equation given, and it is given as y of x comma t, where x is the displacement and t is the time, is equal to a sine of kx minus omega t plus phi. Herein a is the amplitude, k is the wave number, and which will be equal to 2 pi upon lambda. Lambda is the wavelength, omega is the angular frequency, which will be equal to our 2 pi f, and f will be our frequency, and phi is the phase constant, phi is the phase constant determining the initial phase of the wave. Determining initial phase of the wave. Initial phase of the wave, and the snapshot is given at t is equal to 0. So we substitute t is equal to 0. We say at t equals to 0, we get the equation y of x comma 0, which will be equal to a sine of kx plus phi. Let us call this equation number 1. And from the figure itself, if we put x equal to 0, we also get the y will be equal to 0. So you can say from figure at x is equal to 0, y is equal to 0, and dy by dx, that is a slope, is negative. Dy by dx is negative. So we can say that its initial displacement is 0 at x equal to 0 with slope is negative. So from here we can draw one important conclusion, that waves initial displacement is 0 at t is equal to 0 with slope negative. Slope negative. So therefore, again using equation 1. So we can say from equation 1 we can write, putting x equal 0, y 0 of 0 is equal to a sine of phi. But y 0 of 0 is equal to 0 from the figure itself. So you can say, but y 0 of 0 is equal to 0. So this implies that a sine of phi will be equal to 0. A sine of phi is equal to 0, and which basically means that sine of phi will be equal to 0. Sine of phi will be equal to 0, and from here we can say that our phi will be having value of 0, pi, 2 pi, and so on. Now we are going to focus on the slope. Now the slope is negative. So we say slope condition which is our dy by dx is our negative, and we already have the equation that our y of x is equal to a sine of kx plus phi. We derivate it, so we can write dy by dx is equal to a multiplied by k, and here comes cos of kx plus phi. Now it is passing through x equal to 0, so we find out the value of dy by dx at x equal to 0. So we say at x equal to 0, so which basically means dy by dx at x equal to 0 is going to give us a k cos of phi. But slope is negative. You can say, but for negative slope we are going to have cos of phi will be less than 0. So which basically means that value of phi will be equal to pi. And we can just verify this also, whether our answer is correct or not. Okay. So we can say, for verification, once again equation 1, we have y is equal to a sine of kx plus phi. Substituting phi is equal to pi, we say at phi is equal to pi, we get y is equal to a sine x kx plus pi, and this comes equal to as minus a sine of kx. And let us call this as equation number 2. So if we equate equation 1 and 2, so we can say from equation 1 and 2, from equation 1 and 2 we get a sine of kx plus pi is equal to minus a sine of kx. So which more or less gives us that the value of phi will be equal to pi. So this was a small verification step. So if we check the options that are given to us, option number B is the correct option. We can say option B is correct. Is correct. This completes the question. Thank you.